to cancel my unit of grams of oxygen, right? So I'm just going to start off by saying, okay, on the bottom, I should have grams of oxygen, right? And then, so what do you guys think I'm going to put on the top?
Mole?
Yes, it's going to be moles. Here, sorry, let me record it. Oh, is it recording already? Yeah, okay. So it's going to be moles of oxygen. We have to be specific.
Yeah.
And then we're going to say, okay, well, now that we have our grams and our moles, okay, so now we're going to say, okay, well, now we need to cancel out our mole unit, right? So I'm going to say, okay, if I need to cancel out moles, then that means I need to put it on the bottom, right? So I'm just going to start off and say, okay, well, I need moles on the bottom, moles of oxygen, so I can cancel that out. So what am I going to put on the top now? What am I converting to?
Avogadro's number?
Atoms, right?
There you go. So you're going to be converting to atoms, atoms of oxygen. So once we get to here, we're going to say, okay, well, now we have to cancel out atoms of oxygen, right? So I'm going to put that on the bottom, atoms of oxygen. And then what am I converting to? What do I want to find?
Protons.
There you go. Now we want to find protons in oxygen, right? So we've already canceled out all our units. So if we go through the whole thing, we can see, okay, grams of oxygen, moles, moles, atoms, atoms, and we're left with protons, right? So our last step to do is just fill in this entire chart. So we're going to say, okay, well, how do we fill this in? So let's look at this first step over here, this block right here. And we're going to say, okay, well, this thing is saying moles per gram, or in other words, it's saying grams per mole. So what do we have that's in a unit of grams per mole?
The mass number.
Yeah, there you go, the molar mass, right? So what's the molar mass of oxygen?
16.
Yeah, so we're gonna say, okay, that's 16 grams per 1 mole. Does everybody know how I got that and how I put, like, why I wrote it that way?
Yes.
Yeah, okay. Okay, so now that we're looking here, we're gonna say, okay, well, this is our next step. So what am I gonna put here?
1.
Yeah, one.
Yeah, I have 1 mole of oxygen. So in 1 mole of oxygen, how many atoms do I have?
1. No. 6.02 times 10 of 23.
Yes, there you go. In 1 mole of oxygen, I have Avogadro's number of atoms. Okay, so now that we're here, let's go to our next step. So over here to this block. So what goes on the bottom? How many atoms am I dealing with?
One.
We're gonna look at just one of the atoms of oxygen, and how many protons are there?
You'd have to do
Yes.
the calculation. You'd have to do 70.1 divided by 16 times the Avogadro's number, right?
Well, like once, okay, so basically this part of the diagram, this is just kind of like figuring out, hold on, let me move this. Okay, so this is just kind of like putting this into like, what is it? Kind of like conversion steps, right? Once we actually like fill out this entire thing, then we'll get our answer in protons. So like we're not done yet, in other words. So this part right here, we do need to fill something out. So we have 1 atom of oxygen. And so in 1 atom of oxygen, how many protons are there?
Would it be 8?
There you go. So we have 8 protons. So now that we have that, can you guys do the math and show me how many protons this would be?
$2.11 times 10 to the 25th.
2.11 times 10 to the 25th. Did other people get that too?
26th.
Ah, protons of O. Did everybody get 26?
I got 26.
No, I got 25.
Oh, So maybe you just put like one of the numbers wrong or something when you put in your calculator. Also, probably whenever you put in Avogadro's number, be careful. Just make sure to put that into parentheses. That might have also messed it up a little bit.
Yeah, it's 25.
Yeah, okay, yeah. So in other words, we can say, okay, well, whenever I have 16 grams of oxygen, that means that I have 8 protons. But whenever I have 70.1 grams of oxygen, now I have this many protons. So yeah, basically, if your mass changes, your proton count changes.
That,
Um,
for that answer, should we always change it to like 10 to the 23rd? So it'd be like 211 times 10 to the 23rd, or can we keep it as 10 to the 25th?
no, you can keep it as this way. I mean, if they were to give you it like this, it's not exactly wrong, you know what I mean? But I mean, it's kind of like annoying just to have to be moving the decimal around. I would just leave it this way.
Okay.
Madeline, do you have the exam pulled up already or no?
No, let me see if I can get it.
Okay. I'm gonna do this exam. So, okay, the first question. Well, Madeline, do you want to do this one since I've been talking?
Yeah. Okay, so the first question it's asking, if the density of a brine solution is 1.2271 grams per milliliter, how many milliliters are needed to obtain 7.66 grams of brine? Okay, so what do you guys think would be our first step here?
We would write the given.
Yes, exactly. Okay, so what would be our given in this equation?
7.66.
I'm sorry, I don't know if anybody said what the given was. I couldn't hear.
Oh, 7.66.
Okay. Okay. So we have 7.66 grams. So, hold on. If we're looking for the number of milliliters, what would be our next step here?
Looking at the equation for density,
Yes, okay, so can you tell me what the equation for density is?
density equals mass divided by volume, so D equals M over V.
Yes, okay.
And then you would manipulate that to equal the volume.
Exactly, okay. So what would that give us? If we're trying to find volume, what would that give us?
Mass over density, right?
Yes. Okay, so if we're given 7.66 grams, what would, if we're looking for the volume in milliliters, what's our next step here?
Input the value, 7.66 over 1.2271.
Yes, okay. Okay, so can you guys do this calculation and then tell me what you guys get?
6.24.
Okay, what are our units here?
Milliliters.
Years.
Exactly, because our grams would cancel right here. Okay. Does everybody understand how I got that?
Yes.
Yeah.
Okay. Is there any like specific topic that you guys are having trouble with? Maybe I can look for a question that's relating to that topic?
Could you go through number 2?
Number 2? Okay. Okay, so we have a mixture of white beach sand and table salt, which is NaCl, was found. By washing the mixture with water, the NaCl was dissolved and washed away, leaving pure sand. This is an example of separating a Chelsea, we had questions over this yesterday, huh?
Can you hear me?
Yeah.
Okay, I didn't know if I was muted. Yeah, so I got you on this one. Okay, so basically, we look at this and we say, okay, well, we have sand and then we have sodium chloride, right? So whenever you're looking at sand and sodium chloride, you can see, like, I guess I just want you guys to picture it. You can see like all like the minerals, right? Like all like the little rocks. So if you can see a distinct separation between the two, what do you guys think it is?
Heterogeneous?
Yeah, so I'm thinking that you guys are also like in the point where like, okay, well, they're both white. You know what I mean? Like, you know, like it seems like it'd be kind of like homogeneous and also heterogeneous at
Is
the
it
same.
combined?
Um, so okay, here's the thing. So a combined mixture and a mixed company. Madeline, do you remember like the actual definitions for those or no?
No. Let me see if I
No?
can find it.
Okay. Honestly, do you guys does anybody else have the definitions for those? No? Okay. It's because basically I haven't seen those in like, I'm not kidding you, like 2 years. So like I don't exactly remember the definition. So I can't tell you why they're wrong, but they're wrong. Um, okay, but basically, we're gonna look at basically a homogeneous mixture and a heterogeneous mixture, right? And we're gonna say, okay, well, the definition of a homogeneous mixture is that there's no obvious separation between the two, right? It'd be like looking at milk. Like milk is purely white, but there's all this other stuff in there, right? Or it'd be like looking at I don't know, like air or like, it's stuff like that where it just looks the same, right? But whenever you're looking at a heterogeneous mixture, you can see the obvious definition. I mean, separation. So if you have oil and water, or if you have I don't even know that whatever you know what I mean, the heterogeneous mixtures. So whenever we're looking at the sand and the salt, we can see that obvious separation between the two. So I would say it's a heterogeneous mixture. And the reason why I kind of like already like cut out these two was I was thinking like, okay, well, in order to be a homogeneous mixture, it would have to be all like uniform, right? It would have to all look the same. And since it doesn't, then it's kind of like already wrong. So that means that the all of the above was wrong. So that's why I just put B. Does everybody kind of understand that or not really?
Yeah, I get it.
Yeah.
Okay, bet.
So
Probably won't have this question anyway, but what's up?
to be homogeneous, it has to be completely uniform. And if there's like any inconsistency, then it's heterogeneous.
Mm-hmm. Yeah, I would say yes. Um, yeah, okay, yeah. So yeah, I would say yes. Here, I'll let you guys go over the next question. I'll be like researching while you guys do that, and then I'll like come back to you on number 2. So Madeline, can you cover number like 3 and 4 maybe?
Yeah. Okay, so for number 3, we're converting 101 degrees Fahrenheit to the Celsius temperature. So for this one, yes, you would need to memorize between the conversion temperatures. Okay, so can anybody tell me the equation to go from Fahrenheit to Celsius?
5/9 parentheses degrees Fahrenheit minus 32 close parentheses.
Yes. Okay. So then if we're converting from 101 degrees Fahrenheit, then we would plug it in right here where our degrees F is. So then what would be the correct equation that's given here in our answer choices?
A.
Yes, okay. So these other ones, they have like the parentheses in a different place. This last answer right here, it has the 273. That would be if you're converting from degrees Celsius to Kelvin, or vice versa, if you're going from Kelvin to degrees Celsius. So if you were converting from degrees Celsius to Kelvin, does anybody know the equation for that one?
Celsius plus 273.
Yes. Okay. So sometimes I think the questions are going to ask you for the more precise temperature, I guess. So in that case, it would be 273.15. But there are some times where it's okay to just use the 273, but just be prepared to use, like, you remember that there's a 0.15 after the 273 when you're converting from Celsius to Kelvin. Does that make sense?
Yeah.
Okay. Okay, so we're gonna go on to number 4. Okay, does everybody know like what an intensive property and an extensive property are?
Extensive depends on how much of the substance there is. Intensive doesn't depend on that.
Yes, okay. Okay. So do you guys know what density would be? Like from these answer choices here?
Intensive. A.
A.
Yes. So there are some of these answer choices that are just kind of here to trick you. So an excellent property, I'm just telling you right now, that's never going to be one of the answers. An intense property, that one is there to trick you. I think that's just a shortened version of the word intensive. And then really the only ones that you're going to be asked for are intensive or extensive properties. So you just need to know the difference between those two. And yes, you guys got it right. Density is an intensive property.
Okay, so kind of going back to number 2. So I like looked it up. I can't find like literally any definition for either of these. All they keep saying is like, oh, they're mixtures. That's literally all it says. So, but the thing is, like I said before, you already know that homogeneous is wrong, because if it's a homogeneous mixture, that means that it's the same all throughout. So if you're looking at water, if you're looking at vodka, if you're looking at air, if you're looking at rain, whatever it is, like it looks the same, right? But once you start looking at things that kind of look different, like I guess, well, a heterogeneous mixture, in other words, they would have like an obvious distinction of like separation. So if, for example, I think a good one that kind of relates to this is soil. Soil, you see it, I mean, sorry, what? Okay, sorry. Soil, you see it, and it's like basically just like all brown, right? But it's actually a homogeneous mixture. So, I mean, sorry, a heterogeneous mixture, sorry. So I think that kind of like shows you where like homogeneous would just be completely wrong, because like there's obvious distinction. So just know that it's heterogeneous. Yeah, but you won't get a question like that on the exam. I don't know why we're going like so much into it. Are you guys good with that one and all of this like that we've done?
Yes.
Yeah.
Yes.
I think so.
Okay. So, sorry, like this is kind of irrelevant, but is there any other peer leaders in here, or is it just me and Madeline? Okay, yeah, it's just us two. Okay, so I'll go over number 5. So for number 5, let me get an interesting color. Okay, so we have 3.113 miles, and that is how many micrometers? Okay, so first of all, when we start off with these questions, we always just want to go off of what we're given, right? So I'm given the 113. So I'm just gonna work with that. So now that we have this, we know that we're going to be converting. So that's why I already know to do the picket fence. So, okay. First of all, if we don't even know what to do, if we're like, okay, well, what's next? You know what I mean? Just know that if we're going to end up with micrometers, that means that we have to somehow cancel out miles, right? So if we need to cancel miles, I'm going to put miles on the bottom. Then we can start thinking like, okay, well, what goes on the top? So what do you guys think is going to go on the top?
Kilometers?
Kilometers.
Yeah, there you go. It's going to be kilometers. And then after we get kilometers, what do you guys think is next? What are we going to convert to? What do we put on the bottom?
Meters.
Well, if we want to cancel out kilometers, we have to put kilometers on the bottom, right? So we're going to put
Yeah, you're right.
And then, so what's going to go on the top?
Micrometers.
Meters.
I wouldn't do that yet.
Meters?
Yeah,
Meters.
there you go. I would go to meters. There you go. And then, so what goes next? What goes on the bottom?
Meters.
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 So meters. And then, so what goes on the top?
Micrometers.
Micrometers?
Yes, micrometers. Okay, so now that we have all this, let's fill in our values. So what are we going to put in this first section right here? What goes on the bottom?
1.
1, and then what goes on the top?
1.600.
1.6. I'll leave out those zeros because I don't have any room. Okay, so the next one, what goes on the bottom? Well, actually, okay, let's look at these 4 pieces right here. I know you guys aren't my students, so you guys don't know this trick, but I'll just kind of tell you just in case you're kind of confused on how to do this. Whenever you see a prefix, so you see kilo, you see micro, you see nano, giga, tera, you know, any one of those, you see a prefix, what you're going to automatically do is put a 1. So in this case, we see kilo, we're going to put a 1. We see micro, we're going to put a 1. Right? And then we're going to say, okay, well, what's my conversion factor? So we look at our chart, right? Our chart, and then kilo is going to have this one next to it. So we know that this number is what we're going to put in this box over here. So we're going to say 1 times 10 to the 3. And then we look at the other one for micro nanopico. So it's going to be 1 times 10 to the negative micro nanopico. So negative 6. And so you would put this number now up here. I mean down here, sorry. 1 times 10 to the negative 6. So again, remember, if you see a prefix, you put a 1. So can you guys do the math and then tell me what you guys get?
I thought micrometers was 10 to the 9th. Is it not?
Micro, nano, pico. No, so you have deci, centi, micro.
Oh,
Mil-
nano or the 10th.
Yeah.
Okay.
And then micro, nano, pico. Yeah.
Is the answer 0.004980?
0.004980, like this?
Yeah.
Is that what everybody else got?
Yeah.
Okay, so what are the other answers that you guys have gotten? Here, let me put in my calculator. So Actually, I got a really big number. Did anybody else get a really big number?
Yeah, I got
Yeah, I got
Yeah.
4.98.
Like
4.9.
4.98 times 10
10,
to the
10.
ninth.
Yeah,
4.98 times 10 to the what?
ninth.
Ninth.
Yeah, there you go. I got this big number. Okay, so here, let me try to like maybe I can like fix around what happened maybe. So make sure that whatever's on the top, you're gonna be multiplying these things, right? And then whatever's on the bottom, you divide. And then also whenever you input in your calculator, like let's say you're doing 1.6 and then you're gonna multiply it and then do it in parentheses and then do 1 times 10 to the 3. Enter it like that. I don't know if that's like makes a difference in your answer, maybe.
Yeah, that makes sense. I actually put it in like all the way through.
Mm-hmm. Okay, so what I'm gonna do, actually, I'll let Madeline take over right now, but what I'm gonna do is I'm gonna show you guys actually a shortcut as to how to fill out the chart. So basically I made up a mnemonic for the what is it called? I can't forget the dimensional analysis chart, like the kilo
Prefixes.
sorry, what?
The prefixes.
There you go. I couldn't figure it out. Yeah, so I did a mnemonic for that. So what I did is I did okay, yeah, fine, I'll do it here. So I did, oh God, that's an ugly color. Hold on, let me get a better color. Okay, I did thank, and then I said God, man. And then this is from like middle school. I don't know if you guys ever learned this. King Henry died. And then you go to lowercase. Drinking chocolate milk. And then honestly, for the life of me, I can't figure out anything interesting, but I just do micro, nano, and then pico at the end. So basically, if you were to convert this, you would just say, okay, well now I have tera, and then giga, and then mega, and then kilo, deca, I think. And then there's your baseline. And then you have deci, centi, milli, oh, and then micro. I should have written out whatever, micro, nano, pico. And then from there, what I did is I said, okay, well now you have 1 times 10, and then you just go minus 1, and then 1 times 10 to the negative 2, 1 times 10 to the negative 3, and then you go by factors of 3. So you go 1 times 10 to the negative 6, 1 times 10 to the negative 9, and then 1 times 10 to the negative 12. And then it's just the opposite the other way. You would just do 1, 2, 3. Oh, I'm missing one. I missed the Henry. It's just the hepta. I'll write it like super small. But yeah, and then 1, 2, 3, and then it would be 6, 9, 12. So I hope that helped out a little. I mean, that was just like a random fact. But yeah, I memorized this like one time, like right before my exam, and it helped me. So I hope it helped you guys. Okay, you can go, Madeline.
Wait, can you put that back up?
Okay. Which one, the mnemonic or the?
The mnemonic.
Yeah, here, let me write it.
Oh, no, the conversion. Sorry.
Okay, yeah. Sarah, God, so giga, and then mega, and then kilo. And then you would just do times 10 to the negative 1, negative 2, negative 3, and then to the negative 6, negative 9, negative 12, and then the other way around. 1, 2, 3, 6, 9, 12.
This chart is also going to be on page 40 in your workbooks.
Okay, can I erase it? Can you guys like take a picture or something?
Yeah.
Okay, I'm gonna erase it. Ready? 3, 2, 1. Okay, go ahead.
Can you scroll up a little bit?
Oh, yeah. There you go.
Thank you.
You're welcome.
Okay. So what it's asking for here is how many protons, electrons, and neutrons are in this isotope of lithium. Okay, so does everybody know how to find out the number of these subatomic particles in an element? No? Okay.
You can find the protons from the atomic number and then subtract that from the mass number to find neutrons. And then if it's neutral, the electrons should be the same amount as protons, no?
Yes, exactly. Okay, so what we have here, I don't know if you guys can see that. Hold on. Okay, so what it says here is lithium, and then this isotope says 7, 3, and there's a plus over here. Okay, so what's our atomic number for lithium?
3.
Yes, so like somebody said that's the number of protons we have. So we would have 3 protons in this isotope of lithium. Okay, so then it gives you, in isotopes, it'll always give you your mass number up here in the top left. So then to find our neutrons, we can just subtract these two. Okay, so what would be our number of neutrons in this isotope?
4.
Exactly. So we have 4 neutrons. Okay, so then we have this plus over here. What does that mean?
Video anyways.
Okay, yes, I think somebody said it's an ion. So then normally in a neutral atom, our protons and electrons would be the same. But since this isotope has a positive charge, would we add or subtract an electron?
Subtract.
Yes,
Subtract.
exactly. Because if we
Subtract.
subtract an electron, that would make the ion more positive. So how many electrons would we have in this?
2.
2.
2.
Yes, exactly. Okay, so we have 2 electrons. So then our answer would be what from over here? It's asking for protons, then electrons, and then
B.
neutrons.
A.
B.
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 Your answer is going to be B.
B.
Okay, does everybody understand how I got that?
Yes.
Yeah.
Okay.
Wait, hold on. Can you explain how you got the electrons again? My fault.
Yes, of course. And I think somebody asked for the protons too. So the protons are always going to be your atomic number. So in this case, your atomic number for lithium is going to be 3. So that would be 3 protons. Okay, so if I had given you like fluorine, your atomic number is 9. So that's how many protons you would have. But back to the electrons for this one. In a neutral atom, so if I just gave you lithium, just like that, without a charge on it, we already said that our atomic number is going to be 3. So that's 3 protons. Okay, and protons have a positive charge. If this atom is neutral, how many electrons would we need to have?
3.
Exactly. Okay. So in a neutral atom, we have the same number of protons and the same number of electrons. But since this atom, since the one that we're given over here, this isotope, has a positive charge, we would lose an electron. So we would only have 3 protons and 2 electrons. So then we're left with a positive charge because we have 1 more proton than we do electrons. Does that make sense?
Yes.
Yeah.
Okay. Okay, so we're gonna move on to number 7. So we have all these isotopes of hydrogen. The atomic numbers of these 3 atoms are, okay, so if they're all isotopes of hydrogen, what is our atomic number for hydrogen?
It's always going to be 1.
Exactly. So would it change no matter what our isotopes are?
No, it stays the same.
Exactly. So the only thing that would change in your different isotopes are going to be the mass. So which of our subatomic particles would change between the isotopes?
Neutrons.
Yes.
Neutron.
Okay. So since it's only asking for the atomic number of these isotopes, what would be our answer here?
D.
Yes. Does that make sense to everybody?
Could you repeat it, please? Because I didn't quite get it.
Yes, of course. Okay, so our atomic number for hydrogen is going to be 1 because if you look at the periodic table, it's our first element, right? So then between our different isotopes, when we have our mass that changes, the only subatomic particle that's going to change, like the amount of subatomic particles that there are going to be our neutrons. Our protons are always going to be our atomic number. So like we had with our lithium in number 6, we had the 7 up here. That's our atomic mass for our isotope. But then our atomic number was 3, which is right here. So that's our atomic number, and that's the number of protons we have. So our atomic number is always going to stay the same between all of your isotopes, because it's the same element for every single isotope. Does that make more sense now?
Yeah, thank you.
You're welcome. Okay. So now number 8, hydrogen and lithium are in the same, what? Do you guys know what the groups and the periods are in our periodic table?
Yes.
I haven't memorized, but I know
D.
helium's right under hydrogen, so they're in the same group.
Yes, exactly. They're going to be in the same group. So our groups are going to be the vertical columns on your periodic table, and your periods are going to be your horizontal rows. Does that make sense?
Yeah.
Yeah.
Okay. Is everybody okay with that question? Can I move on to the next one?
Yep.
Yes.
Okay.
Yep.
So our next question is KCl and MgF2 are called what? Like, what's the atomic name? Or, yeah, what's the name of these compounds?
Potassium chlorine and magnesium difluoride.
Okay.
Number, it would be C, right?
Potassium chloride.
Yeah.
Yeah, somebody said C. So
Yeah.
our first element, we have, our first compound, we have KCl. So then when you're naming an ionic compound, which means you have a metal and a non-metal, what you want to do is just get the your first element here, your metal, and that's going to be just the name of the element. So in this case, it is potassium, like you guys said. And then with our non-metal, we want to add "ide" to the end of it. So we change the chlorine to chloride. Okay, going off that, our second compound is also an ionic compound. So does everybody understand why it wouldn't be difluoride?
Yeah, because it's an ionic compound, not covalent. Makes
Exactly.
sense.
So if we had a non-metal right here where the magnesium was, then we could include the prefixes. Does that make sense to everybody?
Yep.
Okay.
So covalent's 2 nonmetals and ionic is a metal and a nonmetal?
Yes.
Okay, thank you.
Okay. Chelsea, can you scroll, please? Thank you. Okay.
Do you
Go ahead, Chelsea.
You're welcome. Do you
Oh,
want me
thank
to help you? Are you good?
Oh, I'm okay. Okay. So we have in this next question we have
No,
iron
you're good.
3.
Sorry.
We have iron 3 bromide. So first of all, what
Do we skip some questions? No, never mind.
no. Okay, so iron 3 bromide. First of all, what would be the name or the formula for this compound?
FeBr.
FeBr3.
FeBr3, yeah, at least, yeah.
Yes. Okay. Does everybody understand why it's FeBr3?
Because the charge is 3.
Yes. Okay. So just in case somebody is confused, we have Fe. So in this case, our Roman numeral 3, tells us that this ion has a positive 3 charge. Okay, and then since bromine is one of our halogens are always going to have a charge of -1. So in this, in your ionic compounds, you want to take the charge. What I find the easiest is you take your charge and you put it as your subscript for the other element. Does everybody understand how I got that?
Yeah.
Okay. So then, how many atoms would we have of iron in our compound?
1.
Yes. Okay, and then how many atoms of bromine would we have?
3.
Yes, 3. So you can always find the number of atoms of your elements by looking at your subscripts. So there's an invisible 1 right here by your iron. So that tells us we have 1, and then bromine we have 3. Does everybody understand how I got that?
Yep.
Yeah.
All right. Okay, so moving on to the next one, we have 4 significant figures. What's the formula mass of phosphoric acid? And it gives you our formula here. I don't know if you can see that, but it says H3PO4. Okay, so what would be our first step in finding our formula mass?
Finding the mass of the individual elements.
Yes.
So
Okay.
3 times 1,
Go ahead, 3 times
1, and then phosphorus. What's phosphorus? I don't have my table with me, but
okay. Does anybody else have their table with them?
Yeah, it would be 3 times 1.008. And then phosphorus would be 30.97.
Oxygen is 15.99.
Yes, okay. Okay, so then you said oxygen was 15.99. How many moles of oxygen do we have in our compound?
4.
Okay, so can anybody tell me what each individual thing is? So this one's for hydrogen, this one is phosphorus, and this one is oxygen.
I got 98.
Okay. First, can you tell me what it is for hydrogen?
1.024.
Mm,
3.024.
yeah, it's gonna be 3.024.
Yeah.
Okay, so then what would phosphorus be?
30.97.
30.97.
Yes. Okay, so then what about our oxygen?
63.96.
Okay. All right. And then I think somebody already said the answer. What would be our total molar mass?
98.
Okay, and it's asking to 4 significant figures. Did you get 0.00?
It's like 97.954. So like you just round it.
Yes, okay. So that will give you 98.00. And then what would be our units here for molar mass?
G/mol, grams per mole.
Yes, okay. So for molar mass, you always want to remember that your units are going to be your grams per mole. So then our answer is 98 grams per mole. I know it doesn't have the units over here, but just so you guys know, you always want to make sure you include that. Okay, does everybody understand molar mass?
Yes.
Yeah, I think so.
Okay. Okay, so our next question.
Actually, Madeline, Eduardo, are you here? Eduardo,
Hey guys.
there you go.
So, am I able to write?
I think so.
You know how?
Can you walk me through it? Sorry.
You're good. So at the top, I'm pretty sure it's at the top. I don't know, but it'll say something that it says like, annotate.
If you click on view options, it should say annotate.
Oh, there you go.
Okay. Cool. So the question says, how many grams do 1.222 times 10 to the 14 atoms of carbon weigh? So we're looking for grams, right? What is the mass? That's what it's asking us. So how I like to solve like these dimensional analysis problems is I like to write what's given. So, oh no. So 1.222 times 10 to the 14 atoms is what's given, right? And then I know that carbon weighs how much in the weight?
12.01.
Yeah. Grams per mole. So I like to personally do the fence method. So 1.222 times 10 to the 14th atoms. And then I want to cancel units, right? So I just write Avogadro's number down here. Atoms for 1 mole. So we know for 1 mole, of any element, we have 6.022 times 10 to the 14 to 22nd, my bad. Right?
Not the 23rd.
23rd.
My bad. My bad. Okay, so I'm canceling my units, atoms, turns to moles, right? So moles of carbon. And in 1 mole of carbon, how much grams are there?
12.01.
Right. Yeah, right there, it says carbon. So you pretty much multiply the top and divide it by the bottom. Does everyone know how to set the question up? So I went from atoms to moles, then moles to grams. So atoms to moles, then to grams. Can someone do the calculation? So 1.222 times 10 to the 14.
I got I got 2.437 times 10 to a negative 9.
Same.
Can anyone else confirm it?
Yeah.
I got two.
I got it.
Same thing.
Okay, so what was the number again?
2.437 times 10 to a negative 9.
So from 1.222 times 10 to the 14th, you would have 2.437 times 10 to the 9 grams. That is so ugly, guys. Let me 2.437 times 10 to the 9. 2.437 times 10 to the 9 grams. So just more legible. Does that make sense? Oh no.
Yes.
All right. Maddie, okay. So for 13, C7H16 is called. Excuse me?
Is it propane?
That's heptane, right?
Heptane?
Yeah. So for C7H16, the answer would be heptane, so A. This is an alkane. So if you look in your workbook, page 60, you have a chart. So for 1 carbon, it's methane. 2 carbons, ethane. 3 propane. 4 butane. And after that, it's pretty much easier to remember. So 5 is pentane. 6 hexane. So think of a hexagon, 6 sides, 6 carbons. 7 heptane. That's what I was asking you. C7, which is heptane. 8 octane. 9 nonane. 10 decade. That make sense? Exactly. Mike eats peanut butter. That's how I remember the first 4. And after that, it just becomes a lot more simpler.
Okay, here's the thing. We have another practice exam, but it only goes over module 3. So like my question to you guys is like, do you guys have questions like already that you want answered, or like do you have like maybe from your homework like one you got wrong, you don't understand why it was wrong or something? Like, do you want to go over those, or do you want to just do the one that I have?
Is the test going to be more over like the lecture book that he gave us, like the online lecture book, or is it going to be more like about like the module on the workshop like book, like the modules from the workshop book?
Oh, ouchie. Okay, so you know, I'm not really sure how he okay, here's the thing. I've seen his exams before, and I'll tell you this. I'll tell you his exams are pretty comprehensive. Um, so basically, if you watch his lectures, I know that sometimes he'll like talk about I know there's a point where he starts talking about like stars and like kind of like the protons compared to stars and stuff like this. I don't remember like the actual like speech, you know what I mean? But I know for sure he questions like he'll question you on stuff like that, like his theoretical stuff. Um and then he also does calculations, but I don't really remember like exactly how his exams were, but I do know that they're pretty conceptual based as well. So just keep that in mind. Um, Madeline, did he ever tell you like how he was gonna format them or no?
No, I don't think so. He just told us that it was gonna be over. Like he just told us the chapters it was gonna be over. He didn't tell us like how his test was gonna be formatted.
And then neither of you guys had him, huh?
I
As a
had
professor?
I had part of it.
Yeah, I did too.
Yeah, I would just say just keep in mind that he's conceptual based. I remember a lot of his problems being pretty conceptual. So yeah. Okay, yeah. So what do you guys want to do for this like remaining time? Or are you guys all good, or like what's going on? Wait, I can't. Can you go over the homework?
How long will this like review session be?
We can make it. When did we start? Like 4:30, right? We can make it till 6:30.
Okay.
So here's the thing. I forgot who put it in the chat. Hold on, let me figure out what your name so I can. Okay, it was Jacqueline, right? So I don't. Or actually, I do. Is the homework on his Blackboard?
Yeah.
Okay, hold on. Let me see. Can you guys like see what I'm doing? Are you guys still on like the? Yeah, you can. Oh shoot. Okay.
I think if
What's
you
his
paused
CR?
your sharing, it would have.
No, it's fine. I don't mind if they see. I'm just wondering. Hold on. I just saw a CRN like right now. 11139. Oh, what was this one? Okay. So you want to do the homework 3 or the homework 4? Or homework 5? Wait, I'm not gonna do this one. This one's not even due yet, you cheaters. What do you want to do? Do you want to do? We could do this.
Homework 5, and there's a bunch of like repeat questions with answers that aren't the same to the same question he had before. That assignment was different, I guess.
Did you email him?
I did. I emailed him 2 days ago. I haven't heard back yet.
Okay.
But yeah, number 3 was all screwy. Yeah, homework number 3.
Okay, I'll do number 3. Because I don't want to do these because they're not due yet, and that's cheating. So I'm gonna do number 3. You guys don't even tell me. Look, this one's also due on September 18. I swear, you guys are gonna make me do stuff that's not even due.
I mean, I think
The 7 a.m. one. Do the 7 a.m. one.
Madeline
was
and
already
Eduardo, do you guys think that we should just do it since they're here at the review session making the effort?
I guess, yeah.
Like a
Ooh,
couple questions.
Huh?
A couple questions.
Not all of it,
Like,
like some of them.
Let me see. Let me see. Let's open it. Let's just see what happens when we open it. Okay. I mean, how many questions are there? Oof, that's a lot. Okay, yeah, we'll do a couple.
yeah.
We'll just do like random ones. We'll just like click random things. Okay, so let's do question 1. Isotope N15 has whatever. Another isotope.
Could have 7 protons and 7 neutrons because the protons never change.
There you go. Yeah, there you go. So your protons would never change. So this one's wrong, this one's wrong, and this one's wrong. So this is the only one that's the right option.
Hey,
Protons.
Cameron, can
Yeah.
you explain what would happen if the number of protons changed?
It would be a different element completely.
There you
Bingo.
go. Okay. Random one. Let's do number 5. Group 1 from the periodic table is known as, I don't remember. Do you guys remember?
Yeah.
I think it's
Alkali earth metals, I
Alkali
think.
metals.
Alkali. Alkali metals. Just
It's-
alkali metals.
Yes, it's alkali metals. Group 2 is alkaline earth metals.
Okay.
Honestly, I forget. Okay, let's do this one. Aluminum sulfide. Okay, so here, let's break this one down. So
Al2S3 or Al2S.
we have
Maybe.
aluminum, right? Which aluminum has a what kind of charge?
+3.
+3.
3 plus, and then we have sulfur, which has what charge? Or sulfide.
-2.
There you go. And then if we do the butterfly method, we just crisscross. That's going to be Al2S3. So there you go. Our answer is B. Okay, so let's do like number 15.
I have a question. From looking at the periodic table, is there a way to tell what charge the atom has?
Yeah, that's a really good question here. So let me stop sharing my screen and let me show you that instead. Hold on, give me a second. It's because I have to pull up the picture of the periodic table. Insert picture. Sorry, I'm going, I promise. Okay, so we're looking at our periodic table here. And so basically your first row, right? I guess technically speaking, they want to give away an electron. So they're gonna have a plus charge, sorry. Ah, that's so small, hold on. A plus. Let me actually, hold on, let me see if I can, actually, no, it doesn't give me options. Let me just annotate instead. Okay, so these are gonna have a plus charge. And then you look at the second row, right? Those want to give away 2 electrons, so he's gonna have a +2. And then the next one, this group is gonna have a +3. And then this group is gonna have plus or -4. That's the annoying part. It could be either plus or it could be -4. And then you look at your noble gases, these are gonna be neutral, so these don't have a charge. But once you get to your group of your halogens, so this one is gonna have a minus charge. The next one is gonna have -2. And then the next one is gonna have -3. So in other words, let's say I was looking at here phosphorus. So phosphorus would be -3.
Okay.
So
I mean, it's not really written on there, but it's kind of easy to remember, I guess.
Yeah.
How do you determine the ones in the middle?
Okay, so these are here. These are called your transition metals. So transition metals, the thing is that they don't really have like a designated charge. So what happens is whenever they give you the name, they should say, oh, this is iron 3 chloride. something like that, right?
Okay,
And
so
so
tell you the name.
yeah, the
With the
Roman numeral is
charge.
going to take you with the charges. Yeah.
And is the charge always positive on those?
Yes, it's always going to be positive. And okay, no, I'm not going to get into that. But yeah, it's always going to be positive. So the thing
It'll
is
be
that
positive.
let's say they gave you something where they said, oh, I'm going to make something up like CuBr4. I don't know. This doesn't even exist, but I'm just making it up. So you're like, okay, well, what's the charge on copper, right? What you can do is just get this number and then like push it up and you can, there you go. Copper is 4 plus. So whatever digit is on like the second one, that's going to be your charge on your transition metal. Sorry. Are you guys okay on the actual like what is it, like converting from the grams to like protons and stuff like that? Cuz I have this PowerPoint and it goes over naming, like naming compounds and stuff. Like would you rather go over naming or would do you also need the grams to atoms and all that stuff?
And I'm kind of okay on grams to atoms. I'd rather go over names. I think that one's harder to remember.
Okay, how's everybody else doing on naming? Does everybody want to do the naming PowerPoint?
I think I need some more help with like getting the protons, that conversion stuff, but I don't.
Okay, we have like a mixture. Okay, so I don't know what the chat is saying. Sorry guys, it takes me a while to get to the chat, so like it'd be better if you use your mic. Okay, so if people want to see conversions, okay, that's fine. We can do conversions.
Names would be easier.
I think there was somebody earlier that asked about percent composition. Has Dr. Noveron said anything about like if that's going to be on the exam, because that's not until module 4.
To my understanding, it shouldn't be on the exam.
Okay.
But I don't know if you guys know more than I do.
I haven't heard
homework 4, I'm sorry, it's because on homework 4 there was a lot of like maybe 5 problems on percent composition.
Oh, okay, yeah. So there might be percent composition.
Can we also go over some stoichiometry? Or like practice it a bit more?
He said it was just gonna be modules 1 through 3, so I don't think the percent composition will be on there.
We'll go over it just in case it is on there.
It was on his last assignment.
Yeah, probably it will be then. Okay, so what assignment was it on? It was on
homework 4, I believe.
Homework 4. So
actually it might be homework 5 now that I'm thinking about it.
Oh, do you remember what problems?
It's because I know that the problems are all mixed on everyone's. So
oh, dang it. Okay, that's gonna take too long to find them. Okay, so let me find the percent composition problem. Madeline, you said that was like module 4?
Yeah.
Okay, let me find one. Oh, there you go. Okay, so we can go over that. So
We could go over the examples that they provide.
I'm going over on the sequence facilitation guide or whatever. I got them from there.
Okay.
Okay, so actually let me type it out. I think that'll be faster. Okay, so we have this problem. Oops. Okay, so we're going to calculate the percent composition by mass of all the elements in sodium bicarbonate. So first of all, does anybody know the formula for sodium bicarbonate?
Na C2.
So, okay, so we have sodium, which is Na, and then we have carbonate, which is CO3, right? And then whenever you see bi just means that there's a hydrogen in there. So basically, it's NaHCO3. Ah, dang it, I erased the question. Whatever, you guys saw the question though. Yeah, oh, I can undo, near me. Oh, is this taking too long? Okay. I did it again. Whatever, just leave it there. Okay. So we're gonna calculate all of that. So okay, so for basically whenever you start with percent composition, right? What you want to know is first of all, what's in your compound. So you have here you have sodium, you have hydrogen, you have carbon, and then you have oxygen. So once you're going with all of this, you're gonna say, okay, well, what is my total mass? So can you guys tell me like the total mass of the entire compound?
Would it be like adding the masses of all of those
Adding
atoms?
the mass of all of them.
Yeah.
Yes.
And then do you multiply like the oxygen one by 3 because there's 3 of it, or no?
Yeah.
Yes.
Yeah, you do. It's
Okay.
There's a lot of, like, you have to get the mass of the entire element and then, or the entire,
With the total
For
mass
the
of the
mass, I got
person, 84.
83.978.
83.978.
Yeah.
Okay. So now that we have our total mass, we can break it down now. So we can say, okay, well, okay, here. So whenever we're doing this, we're gonna say our mass of our element over our total mass, right? So what's my mass of sodium? Like by itself?
22.990.
Yeah, so it's gonna be 22.99, right? So then I'm gonna divide it by 83 point, I'll do 98. And then we're gonna multiply it by 100%. And then we go to hydrogen. So hydrogen is 1.008, right? And then we're just gonna divide that again by the total. So 83.98 times 100%. Then carbon is 12.01. And then again, 83.98 times 100%. So that's the fun thing about this. It's like the same thing over and over again. And then oxygen, what mass do I put for oxygen? 16?
16.99.
Yeah, 16.
Yeah.
Well, remember you guys, I have 3 moles of oxygen. So we need to multiply that 16 times.
16 times 3.
So what is 16 times 3?
48.
48.
Okay, bet. 48 divided by 80. Ah, I don't even know what I did. 83.98 and then times 100%. So can you guys get me those numbers, like starting at sodium?
The sodium one is 27.38.
Okay, the next one?
Isn't
1.2008.
isn't 100% just 1? Like when you just multiply by 1.
Oh, I mean, you're trying to get the percentage, so it's just moving the decimal place.
Mm-hmm. So what's carbons?
14.301.
And then
57.16.
yeah, there you go. Now that we know all the percentages for every single one of them. So you're just gonna do this process every single time. Whenever you're given a percent composition, you're just gonna do the mass of the element over the total mass and then times 100. And then just don't forget to multiply any of the extra moles that you may have, like the 3 oxygens. So are you guys good with that, or do you want to do another one, or?
Good with that.
Okay. So William and Maddie, what do you guys want to do next? I mean, William, Eduardo, sorry. It's because I was looking at one of my.
I mean, we had a big request for nomenclature, right?
Oh, you're right. So do you want to do the PowerPoint? I mean, yeah, the one that I said that I have, or? Yeah, we'll
Sure.
do it.
I just want to add, like, for percent composition, a good way to check yourself is add all of your percentages once you're done with all the calculations and see if it gives you 100.
True. That is a good point. Oh, I think I deleted it. Hold on, let me go to my recycling bin.
I have a question real quick.
What's up?
When you're doing the calculations, like the percent composition, I know like sometimes the periodic tables are different and they give you like different masses for the elements by like terms of like a thousandth of a decimal place, or like when you round, is there like if like you get an answer that's like 15.99 and you put like 15.9 something else, like is there room on the exam for like rounding? Like if you put something close to the answer, will he still give it to you, or does it need to be like exact?
Well, I don't think that he's gonna give any like free response. So if anything, if your answer is really close to one of the ones he gives, then just like click one of those. But even if he does give a free response one, I'm pretty sure, because what you can do is you can like set a range of like what the students can answer, and if you're in the certain range that he wants you to be in, then he'll count it right. In other words, but I don't think you should have a problem because the periodic tables are close enough to where everybody should get around the same answer.
Okay, thank you.
You're welcome. Okay, so you guys can see my PowerPoint, right?
Yep.
Yeah. Yeah?
Yes.
Okay. So I'm just gonna go through every single one of them and then you guys can help me out. So I don't know if you guys, Madeline and Eduardo, if you guys wanna like break every single one of them down or something, like if people have trouble.
Yeah.
The first one. So this one.
Maddie, do you want to take this one? Or you want me to go first?
Yeah, I can take this one.
All right.
So first of all, we talked earlier about like ionic and covalent compounds. So would this one be ionic or covalent?
Ionic.
Ionic, okay. So I mentioned earlier how to name our first element. Hold on. So what would be the start of our name if we're just looking at this one right here?
Barium.
Yes, okay. So we have barium. Okay, so what's our second element right here?
Chlorine.
Right.
Barium chloride.
Okay, so our second element here, and yes, I heard somebody say it, when you're naming an ionic compound, you want to change your suffix right here to "ide." So our name for this one would be barium chloride. And I know there's a subscript here, but that's just telling you like what the charge is for our barium. So in an ionic compound, you don't need to include a prefix for your subscripts because if it's an ionic compound, you should be able to figure it out by separating your elements. So then your ion for barium is always going to have a charge of +2. Does everybody understand how I got that name?
Yes.
Yes.
Okay. Chelsea, I don't know if you want to go on to the next one.
Oh, sorry.
All right, so K2O. So, like Maddie mentioned, first we should determine whether this is ionic or covalent. Can someone tell me what type of compound it is?
Ionic?
Right. We could tell because potassium with
Metal.
K is found in group 1. And group 1 are metals, right? So this eliminates the need for prefixes, right? So what would we call this? So we have K, which is potassium. And what's O?
Oxygen, so it's potassium oxide.
Right. So it's potassium and oxygen, but when you're in a compound, you want to add the "ide" at the end. So like Cameron said, it's potassium oxide. Any questions on that one?
No.
I don't think so.
Okay, cool.
Okay, so first of all, we're going to determine if this is ionic or covalent. So can anybody tell me what kind of compound this is?
Ionic?
Yes, okay. We know that because magnesium is going to be, it's one of our metals in group 2. Okay, so we start off with magnesium. Okay, does anybody know what this is called? Your OH?
Hydroxide?
Yes. Okay, does anybody know if that's the proper name or do we need to change anything?
I think that's the proper name.
I think it's good.
Yes, exactly. Okay, so whenever you have a hydroxide here, it's always just going to be your metal and then hydroxide. So we're done with this name. Does everybody understand that?
Mm-hmm.
Yeah.
Yes.
Okay.
I'd like to add to that real quick. So typically when you have OHs, the charge of it would be -1 because your oxygens are -2, your hydrogens are +1. So that would make it -1. Magnesium has 2, so you need 2 hydroxides.
Yeah,
So it would be neutral.
Equation. Got it.
Okay, so step 1, like we've been saying, what kind of compound is this?
Ionic?
Ionic.
Right. Like previous potassiums in group 1. So we could start by naming the first element. Can someone tell me what NO3 is?
Ammonia?
Nitrate.
Oxide?
Nitrate.
Yes.
Nitrate.
Nitrate. Potassium nitrate. You see how there's no subscripts for potassium? It's a -1 charge, so they go together cleanly. Because that's potassium's group 1, nitrate has a charge is -1, so they go together well. So yeah, potassium nitrate.
So if the element has like an O3 with it, is that usually just turning it into an 8, like nitrate?
Yeah.
You also have to be careful though, because in this case, you're looking at this and you're saying, okay, well, where did I actually start off on, right? So if you actually take this compound apart, we had K plus and NO3 minus, right? But let's say they were to give you NO3. So this one down here is nitrogen trioxide, because this is a covalent compound. But once you add in this charge, that's whenever it's the nitrate or carbonate or whatever it is. So just be careful. Just because there's O3 doesn't mean it's a polyatomic oxoanion.
All right. Thank you.
You're welcome. Um,
Okay. So step 1 for this one, what kind of compound is this one?
Ionic.
Yes, okay. So what's the name of our first element here?
Iron.
Iron.
Yes.
Iron 3.
Yes, I heard somebody say iron 3. Okay, can you explain why there's a 3 there?
Because when you put the charges back to each other, iron has a charge of +3, and you need to write it in.
Yes, exactly. Okay. So what would be the last part of our name here?
Chloride.
Chloride.
Yes, we would have chloride. Because remember, we always want to change our suffix here to "ide" when we have an ionic compound. Does anybody have any questions on that one?
I don't think so.
Okay.
All right, cool. So, assume, step 1, like we said, what kind of compound is this?
Ionic.
Right. It's kind of given away by the charge, right?
Yeah.
Okay, chromium sulfide. I mean, yeah, chromium. My bad. Chromium. So, like Chelsea mentioned, we could use the butterfly method. Excuse me.
did you finish this one?
Oh no, I didn't finish my explanation.
Oh,
My
sorry.
pen was being wacko.
There you go.
Okay, so like Chelsea mentioned, you could do the butterfly method. And then if you look on your periodic table, sulfurs are a charge of -2. So then chromium 3 sulfide would look like this. All right, we're ready, Chelsea.
Okay. Actually, okay, so what we can do now, since we've done like a couple naming ones, I don't know if Madeline and Eduardo, if you guys want to just like share a whiteboard and then just kind of like make up problems of like converting from like grams to protons or something, or grams to atoms or something.
Sure.
Yeah. Eduardo, do you want to share a whiteboard or do you want me to?
Um, go for it first.
Okay. Okay. Okay, so I had one, hold on. Okay, so if I give you like 62.9 grams of magnesium bromide, okay? And I'm looking, I want to find protons. What would be my first step here?
Find the mass of magnesium bromide.
Okay. So does anybody want to tell me what the mass of magnesium bromide is?
Magnesium is 24.305.
Okay.
Bromide.
79.904.
So 74.904 times 2.
Yeah, let's not forget that we have a 2 in the subscript. I mean, yeah, subscript.
Okay, so what would be our molar mass of magnesium bromide?
$184.12.
Yes, exactly. Okay. Okay, so would we put our molar mass on top or on the bottom in our next block right here?
On the bottom.
Yes. Okay. All right, so what are our units on top?
1. That's 1 unit of magnesium bromide.
Okay, what are our units right here?
Moles.
Yes.
A mole.
Okay. So what would we put as our units on the bottom of this next block?
1
mole.
1 mole.
Yes, 1 mole of
What are we
magnesium.
trying to find the number of protons for? Like the whole formula, or just one certain like element?
We're trying to find the number of protons that are going to be in your 62.9 grams of magnesium bromide.
So the whole.
Yes. Okay. So what do you guys think our next step? What are our units up here on top of this next block?
Avogadro's number?
Adam?
Oh wait, hold on. Here. I'm gonna have you guys find the protons of magnesium. Sorry, I forgot to add that in there. Okay, so I heard somebody say, what was it? What goes on top here?
Adam?
Avogadro's number.
Yes, atoms, and then Avogadro's number. That's a 0. Okay, so we have 6.022 times 10 to the 23rd atoms. So what's our next step if we're looking for protons of magnesium?
So there is 1 atom of magnesium and magnesium bromide. So 1 over the mass of magnesium.
Right.
Which was 24.305.
Yes, actually, hold on.
Wouldn't you put atoms to the bottom to cancel out, and then
Yeah.
an atom of magnesium?
And then
So you're
protons on top.
Actually, I want to mention something. When you're dealing with a compound like this, instead of atoms, it's going to be molecules. If you're just dealing with atoms, I would have given you like just magnesium to start off with. If you're finding the atoms of a substance, you're only dealing with one element. But if you're finding the molecules, it's going to be related to a compound. Does that make sense?
Sure. I think so.
Okay. So instead of atoms right here, it's going to be molecules. So then what would go on the bottom of our equation down here?
Molecules.
Yes. Okay, and then how many molecules would we have? This is magnesium bromide.
One.
Okay, so what are the units on top of this block right here?
1 magnesium.
Grams of magnesium.
1 magnesium.
Yes. Okay, so we're gonna say it's 1 mole of magnesium. Okay. So then what are the units on the bottom of our last block?
1 mole.
1 mole.
Okay. Yeah, 1 mole of magnesium. So what are our what goes on top right here?
That would be the atomic mass of magnesium.
Okay, so it wouldn't be atomic mass. If you're looking for the protons, it's going to be your atomic number of the element.
1 magnesium then?
12.
Yes, it's going to be 12 protons.
Yep.
Okay, so can somebody complete this calculation for me to figure out how many protons of magnesium we have?
Couldn't you also like reverse the put the third kind of bracket, like switch the third and the fourth so that the fourth one is
Yes, you could. So what you're saying is hold on. So we have our 62.9 grams of magnesium bromide here. And then we have our
2.46 unit of 24.
Okay, and then personally, this is the way I like to do it because I think it's a little bit less confusing. I think what you're saying is you put the 1 mole right here, right? And then
right. Yeah. Over, and then on the top would just be 1 mole. Yeah.
yes, you could do 1 mole of magnesium. It will still give you the same answer because we can just put this third block right here. Right here. That's a 0. And then it will still give you the same answer. I think it's a little bit less confusing this way, personally. But it's the same calculation. So either way you want to do it is okay.
Okay, cool.
Would the answer for the calculation be 2.459 times 10 to the 24th by any chance?
Got 2.46, 10 to the 24th, but I mean, it's basically the same.
Okay. I don't know if you guys noticed, but right here, I put atoms because now instead of the compound, we're just dealing with magnesium. Does everybody see that?
Yeah.
So we have Avogadro's number of atoms in 1 mole of magnesium. So atoms are just going to be relating to if you're only dealing with an element. But up here I put molecules because we were dealing with a compound. Does everybody understand why I did that?
Yeah.
Okay. Does everybody agree with this answer?
It looks clean. Looks good.
Okay.
Okay, so
Any questions?
so basically to get protons, you just have to do like the calculation to get to atoms, but just multiply, by how like the atomic number of the whatever like you're trying to find, basically whatever element you're trying to find.
Yes.
Okay.
If there's 2 atoms of magnesium, would it be 24 protons when you multiply?
Yeah.
No, you would put, so if there had been 2 atoms of magnesium, we would have instead of right here. So say this had been 2. This isn't a correct chemical formula, so don't ever write that. But there would have been a 2 right here for the moles. Does that make sense? So the number of moles of an element in your compound is going to be the subscript that's given to you in your molecular compound.
Okay.
You keep that up for 1 second.
Yeah, do you want me to, let me fix this real quick, hold on. Okay. Does anybody else have any more questions on this?
They can ask for electrons or not?
Normally they're not going to ask you for electrons. It's normally just going to be like from grams to protons or moles to protons or something like that.
Okay.
So if we were to do moles to protons, that would just be.
You would just skip this first step over here.
Okay.
And you wouldn't have to find the molar mass. You would just start with whatever moles you were given and then follow these steps. Does anybody have any more questions on this one? Okay. Did everybody, am I okay to erase this now? Did everybody like get a picture of it, write it down?
Oh, Maddie, can I say something real quick?
Yeah, go ahead.
Okay, so for example, like if you're given like a conversion question like this on your exam, and it gives you like this amount of protons, and it's asking to convert to grams, how would I do that? You just do like the exact opposite, right?
Mm-hmm.
So they give you this amount of protons, and then you have in one atom this amount of protons, and then yeah, you keep converting till you get grams. Just in case they ask you that type of question, you're just doing the reverse. Does that make sense?
How would that actually like play out in like an equation?
Because I think I saw it recently, like on a study guide or something. So for example, so you have this amount of protons, right? And it's asking for grams. So you would then put like in magnesium specifically 12 protons in one atom. And then in one atom, you have 6.02. Oh, my bad. You have 6.022 times 10 to the 23rd in 1 mole. And in 1 mole, you just put this number right there. And then you just multiply, and then you divide. And then that would give you your answer. It's just doing the exact same opposite.
So you do the same equation, but like flip everything from bottom to top.
Yeah.
Exactly. You're just doing the opposite. You see how from Maddie's problem, we're starting from grams to finding protons? We're starting with protons and we're trying to find grams. Just in case they give you a question like that.
So if you guys look at this diagram up here at the top, it'll show you like if you're going from grams to moles, you want to divide by your molar mass. But if you're going from moles to grams, you're going to multiply by your molar mass. And it just takes you all the way from grams to protons. So you can start anywhere in that diagram. Like if they give you moles and you want to go to protons, just follow the arrows for your conversion factors.
Also, yeah, like Chelsea mentioned in the chat, we have a peer leader channel, and we posted every module explaining each topic. So if you wanna, check that out, or you're still having questions about like conversions or nomenclature, then yeah, you should subscribe and watch those videos. All right, cool.
Okay, so am I okay to clear the whiteboard now?
Yes.
Yes.
Okay. Eduardo, I don't know if you have a problem or if you guys have any more last minute questions.
Do you guys want to work on like one more conversion, or do you guys want us to answer questions that you guys have?
Just do another conversion.
All right, cool. So let's say I'm given 300 grams of carbon. I just want to find the amount of atoms in that. So I want to go from grams to atoms. Not in this. We're not going to do protons this time.
You take the grams, the 300 grams, divide it by the mass of carbon. So
All right.
divide it by 12.011.
So, this is grams down here, right? What would go here?
Moles, 1 mole.
Right. For 1 mole of carbon, we have 12.011 grams. So then what would go down here?
Atoms.
1 mole?
1 mole.
1 mole, right? Because we want to cancel out units. So 1 mole of carbon. And what would go here?
Avogadro's number.
Exactly. Which is 6.022 times 10 to the 23rd atoms. So what I like about this method so much is that you could just cancel. So grams is out of the equation. Cancel. Moles is out of the equation. And we have our desired unit. So can someone do the math? 300 times 6.
0.504 e to the 25th.
Can you say it again?
At 1.504 E25.
Times 10 to the 25?
Yeah.
Can anyone confirm this? Or you got a similar number?
That is correct.
Excuse me?
That is correct.
Okay. So yeah, the answer is 1.504 times 10 to the 25th atoms of carbon.
I just have a quick question about like significant figures, because in all of Professor Noveron's assignments, it seems like he makes a big deal out of significant figures. So like in this one, is it 3 significant figures because of the decimal places and carbon and the mass of carbon?
All right. Well, yeah. So if we're talking about significant figures, it'd be 1.51 because 300 has, well, it's ambiguous, but it could have 3, right?
Yeah.
So we just round it like that. So we only have 3 now. But usually, I don't think they'd be so picky about sig figs on this type of question. But yeah, just good to be clean with your sig figs.
Okay, thank you.
And you always want to follow the number of significant figures that are like in your given problem. With like any of your conversion factors, you can see that like the molar mass of carbon has 5 significant figures, but you always want to follow what's given to you, not any of your conversion factors.
Yeah.
Okay.
Does anyone have any questions about the procedure?
Think I'm good.
Anyone else? All right, cool.
So it seems like nobody else has any questions, and you know, we've already like exhausted all of our time here, and you guys are probably tired too. So we'll be sure to post this recording either on the professor's page or we'll post it to the YouTube channel. So just make sure that you subscribe to that, you know, not trying to get the clout or anything. But so yeah, we'll see you guys on the next review session, and then good luck tomorrow. I'll stay behind just in case you guys have like last minute questions, but other than that, the review session is over.
Thank you. I appreciate your help.
Okay, bye.
Thank you.
Thank you.
Good luck, everyone. Subscribe and like those videos.
Marco, there's a link. If you scroll up, there's a link, but it's called Chemistry Peer Leaders.
So you said it's gonna the exam is gonna open at midnight and we're going to have 24 hours to complete it?
Yes.
Okay. Thank you.
You're welcome. Okay, I think we're good to go, guys. Bye.
Bye.